Welcome to Jaxx Vane Studio live number 13. Oh, number 13 on a Friday. We're live on Twitch 3 times a week. You remember, maybe you remember from last time, I had quite a time working on the physics. Yesterday, it was a day of long studies for me and try to understand a lot of things. I will try to go through the various discoveries that I did. This is the situation as of now. As of today, you might notice that I've added, hey Michael, good morning. I've added these lines on the sea, and this is something that I really needed in order to understand really in what direction I was going. I also started to work a little bit on a possible UI, so I added this thing where you can see the wind direction, because again, I have the wind direction with these vectors there, but I found that it was quite difficult for me, and I was losing the feeling of where I was in relation with the wind and what direction I was going. Now, let's go to the foiling situation now. It's a very tricky balance, and I decided that there is no point really for me to just try to do this by throwing code and numbers at the screen. I need to understand properly what's going on and in order to make it work. So right now I have a couple of problems. My first problem is I don't understand why my right side of the boat comes out of the water faster than my left side. So my left side right now is still, it's still on the water, and I can see this because of the blue line. And now, okay, now we're flying. So now both are flying, and what I discover is that now sail control becomes essential, because what is happening right now is that if I don't start to control my sail, basically the roll and the pitch of the boat becomes impossible to control. Not that it is easy now, but at least I have a way to control it out. What has changed from last time that made it a little bit more drivable is that if you remember last time, I had the foils deciding if they were underwater in a sort of on-on, off-on fashion. So they had like a point in the middle, and if this point was above the water, they will decide that the entire foil was out of the water. And if it was underwater, they decided that the foil was underwater. Now the calculation is more refined, so they figure out how much of the foil is out of the water. So they adjust the area, and so the force that foil is creating. What they are still not doing, they are still not changing the application point. So what is happening, what is going to happen is that as the foil is raising up, although the area is changing, the application point will stay there, while in reality you would expect the application point should go down. So we can see here that we are raising the foil. It's way more stable than it used to be. We're raising the foil, and the point of the application of the force remains there, which is something. It's going to be a big part of what is coming for me next week, is that the reason why the actual foil has got this interesting shape, and there are a couple of reasons. One very interesting is that, let's try to ignore this and just think about this foil as it is right now, like this. This has very interesting implication for pitch control, right? Because if you imagine this boat as it's foiling, is basically a balance between the lift generated back here and the lift generated over here, right? So what is happening is that if there is more lift generated here than here, right, the boat will tend to pitch up. And this is something that is very dangerous, because you get in a situation where the more you pitch up, the more there will be angle of attack on this, and the more the boat will still try to pitch up. Now, this is something that boats are different from planes in this, because planes from a certain point of view are easier, in the sense that with plane you have the luxury of having the possibility to have the plane go up and slowing down. And so what planes usually do when it comes to pitch stability is like they oscillate and slowly dump down if their configuration is correct. They slowly dump down to a situation where they eventually find the speed to flight level. Now with boats, we cannot do that. We cannot have excursions of hundreds of meters as the boat is finding his pitch balance. The pitch balance should come straight away. And now having the board inclined, even more inclined than this, is a very clever way to handle a situation where you can imagine if we have too much lift in front, we come out, and if the foil is completely parallel to the water, what is happening is that the foil will come out of the water all in one, right? So it will come out from the water all in one, and it will lose completely all the lift, right? The boat will fall down and it will get into this state. Right now in my simulator, oh my God, it's so complicated to explain, but right now in my simulator, what is happening is that with this happen, it goes out and then it starts to sort of get into this mode where it's bouncing on the water like this, which in reality doesn't happen because of a phenomenon called ventilation. And so what is happening is that as the foil is hitting the water, it's bringing some air on the top, so it's making it possible for the foil to have the same lift. So I will have to simulate this as it drops down. But what is the point? The point is that if the foil is angled with relation to the water, what is happening is that the foil will not come out of the water all at the same time, but it will start to come out from the water slowly. And as this is happening, the actual area, submerged area of the foil will go down, and so the lift of the foil will go down, and that give us a sort of automatic stabilization effect to the foil. So that's very clever. The way this is shaped, I think I will have to actually recreate this in the physics. So I will have to basically write a code that instead of doing with a flat foil like this, it's actually subdividing the foil into panels, a little bit like X-Plane does it, if you're familiar with X-Plane and the blade element theory. So something like that. So instead of having just one wing where things are calculated, this will have to be all separate. And the way this is designed this way is to do exactly the kind of job that I was explaining to you. So as this thing comes out of the water, the amount of area of the foil goes down, and so the boat is automatically repitching down. MK Wendell, thank you very much for the follow. Last thing is that I also implemented something called submergence factor, which again is something that I don't have I don't have the book here. Here it is. This book is literally saving my life. So big shout out to Ray Velinga. This book is really saving my life because it's got so much insight into a lot of effects that I had no idea existed. And it's really helping me to clarify what I'm trying to do. But it's way more complicated than I initially thought, which is often the case when it comes to software in general. I don't know why, but humans tend to have this tendency to underestimate tasks that you don't really know. It could be a product of the Dunning-Kruger effect, where when you start on something, you think you have everything figured out, but you really don't. The more you dive into it, the more you understand how little you know and how much you have to work on this. So my plan for today is to take it easy on the physics. This is not something that I will solve in one day. It's going to be small steps every time. So I added a lot of things in my to-do. I won't do all of this, and I will not do all of this in these orders. We proceed. What's the idea with the location scenario? So I was saying that for me, it was very difficult the other days to just choose a direction and go for it, right? Because everything was C. I had absolutely no reference point, especially if I'm trying to go 90 degrees and I don't even have those marks to help me. So lines definitely help me, but what I'm going to do with the location idea, which is something that we'll eventually have in the game, is to have something around that almost will make it look like we are in a lake. So I will have like mountains in the background, the boat. So the idea is to use this terrain model that the lovely Jaxx just did. Right, so that's the idea. So load something like this. Okay, so this is pretty much what we need. But I know already that we will need something else. So let's see how it looks. Let's see. As first attempt. Yes, we didn't render it. So self location render RDR. Right. So this is what we have right now, and as expected, we will have to tweak the position of this. Let's go 2,000 meters. Is it actually doing something? No, I know why it's not doing something, because I need update bones. Right, so model update bones. If I don't do update bones, it's not going to overspeed. Hey, good morning. All right, so definitely 2 kilometers send it down. Too much, so let's try 200. All right, that looks like what we want. We're happy with this location thing. Love, I think if you could, you still have the model of the original one. Probably if you can scale it a little bit, it looks exaggerated. It looks like I'm in Mordor or something. The rotate, that's correct. They should rotate. So you imagine this flat. I'm always talking to the microphone as the cam is here. The cam is like, so look at me. No, look at me. So this is flat. It becomes like this. So you can imagine the normal here should do. I think our offset can go even a little bit more. Yeah. this guy. So location is done. Let's do this pose mode. All right, this should be, in theory, something that is almost already there. So let's see if it works, because what I really want is not only the pose, I want the entire vector system to stay there. So bang, all right, and I can move around. It's cool. It's a little bit like a matrix effect. So I can pose this thing, keep all the vectors around so I can see what is doing what. You know, now I can use those mountains. You know I want to point at that guy. And if I keep pointing at that guy, I'm staying on the course that I want. And this is the moment where it starts to get really hard, and I can pause it. And I will be able to go over it and see what is happening, which is really cool. Somehow limited if you want a long replay. The nice thing about this game is that races on this kind of boats are very short, like 10, 15 minutes race. So it really matches really well with the video game, right? You play, you go for a race, 15 minutes and you're done, right? Go to next race. The other thing that I really like compared to racing games is my idea is to not to have collisions in this game. So the way it works is sailing has pretty precise rules about who has got the right of way in various situations. So my idea would be to be able to show on the screen if you are green or if you're red. So if you are in a situation where you have the right to stay where you are, or if you are going to get a penalty. And if you collide with somebody, you will simply get a penalty. And compared to racing games, there will be no way for stupid people to just connect and ruin the race of everybody else, because they won't be able to crash into you. And if you have the right of way through to a certain part of the water, you just stay where you are, and the other guy will get a penalty. As simple as that. Nobody is going to be able to ruin your race. It'd be probably interesting to have a key that will trigger only one physics integration. So only one step. Right now, it depends on how fast I can press it. O should give me one step of physics. Doesn't work. No, F10. All right, okay. That's cool. So now we are seeing basically one step of physics. In this case, it's something more than that. It's a special return value. And Rust is really expecting you to do something with that return value. And if you just ignore it, it will give you that warning. So, right, okay, so now we have like 10 physics steps. Yeah, and it looks to me like it's moving more than before. So like 30 seconds up. This could have been really useful in Assetto Corsa to have. I never thought about this. I didn't have all this thing in Assetto Corsa. I didn't have all this automatic visualization of every force that is acting on the system. Would have been also cool to have. Right. Gamepad vibration. So Let me remember where I have my X input stuff. Okay, fair enough. And how I set this? Set state. Fair enough. So let's do public. I wonder if you can hear it. I think you cannot hear it because of the NVIDIA thing. Let me turn off so you can listen to the glory of my desk vibrating. Thank you, NVIDIA. It's gone thanks to NVIDIA. Now, the question is, what are we going to do with this? One thing that I could check is the amount of damping force I hate the fact that I'm stuffing something about vibrations in a function that has absolutely nothing to do with vibration, and I'm hating myself for this. I know I will hate myself in 1 year from now when I will stumble into this and I will think, what the fuck I was thinking. Jesus. Let force to distribute. I'm gonna hate myself when I will see this. And I will go back to this video saying, I told you so. This shouldn't be here. This shouldn't be here. I would imagine the boat, the thing to vibrate as the boat is at the beginning is sort of vibrating on the water and then sort of calm down. And if I start moving, it should start again. Let's see. Let's see if it. Okay. Will you calm down? I think I need a scaling factor. All right, okay, so I'm still not happy about this. I still think that this vibration can be way less than what it is. Especially when the boat is not moving. So we're almost zero. Are we waiting for something? Maybe the books. The vibration is going up. I hope it's coming through. I'm curious to watch this video later. And then I get on a foil and everything becomes quiet. I still have my left side in the water. Come on, go up. And it's all gone. Completely gone. It's cool. Amazon. The rules in practice. Good bedtime reading. How to read water. That's cool. And what else? Getting started in sailboat racing. Yay! What we do next? What am I in the mood to do? Mark buoys not floating. Well, considering that I have waves, that's what time it is. It's almost 12. This should be super easy because I have the formula. The only thing I basically need the C, which is already public. Are you moving? It's not moving. Update bones, Stefano. Update bones. Jesus. And now they're doing it. Right. Okay. Fate in software reestablished. Right. It's moving. My gamepad is... Oh, this looks so cool. I love external cameras. I really love them. I have to do something like that just show an element of the movement of the boat that you can't appreciate when you're watching from very cool. Very happy. Texture override. Let's do texture override, which is basically support for skins. Right? So we should see a red boat, or maybe a crash, or maybe an orange boat. Let's see which one. Orange boat. So it didn't work. Orange or red? Still orange. Why? Checking override texture. Content. Boats. Boat 1. Skins. Red. Okay, it's missing. There you go. Orange or red? Yay! There you go. Okay, let me try the purple one then. Yay, I got the purple one in game, baby, for the first time. I can do it very easily now. If you send me your crazy one, I can try. Let's see the unicorn. So we close the stream with the unicorn. Oh, yes. There you go. Look at that. We got a foil with this thing. We have to foil with this. I need to attach the... I cannot foil. I need to attach the camera to the boat. Yay! Amazing. It's going to be your boat, right? Right? When we race with this, we test the multiplayer, you're going to be playing with this boat. Right. Okay. We're done with the texture override and it's 1 o'clock. And I think we can call it a day. If you made it through here, thank you very much, guys, for watching. If you see this on YouTube, you can follow on Twitch. You can follow me there, subscribe there, or follow me on YouTube, and you will get highlights from every stream. My next stream is going to be Monday morning at 10 o'clock, and I will see you there. Bye-bye and ciao.